Hi everyone, in today's session we are going to see about deadlock and what are the characteristics of deadlock. In the entire topic of deadlock, it covers the deadlock characterization and the methods of handling deadlock. Methods of handling deadlock is of four segments, that is of deadlock prevention, avoidance, detection and recovery. Under deadlock avoidance, we will be seeing the important Banker's algorithm for resources of multiple instances. Let's see that on further classes. Let's start the session. First, let's see what is a deadlock. A deadlock is nothing but when a process requests for a resource which was needed by the process for completing its work. In that state, if that resource which was requested by the process are already available by another process, then this process has to enter the waiting states. In that situation, the process which is waiting in the waiting queue may never be able to change the state because the resource which is requested by the process are held by other waiting process on the queue. In this situation, the process which requests the resource can't be granted and it will be stayed on the waiting queue for a long period. This situation is called as an deadlock. That is only mentioned in this slide also. That is nothing but the system consists of resources. In this, the resources instance are mentioned as R1, R2 till Rm. In this, the CPU cycle, memory space and IO devices are being shared by the processes, and each resource R1 will be have to wait for an instance of WI for accessing all those memory space, IO devices, etc. In such a situation, when a process needs a resource and if it is in a state to utilize that resource, it has to follow three steps. The three steps are: the process must request for that specific resource. After requesting, if the resource is getting available, then the resource will get allocated for that process, and then that process must use that resource. After using that resource, after completion of its work, then that process have to release that resource. After releasing the resource only, that resource which was captured by that process will be freed and it can be allocated for further processes which are waiting on the waiting queue. These are the three steps to be followed by a process for utilizing an resource. That is only given here. A process must request for the resource, and before using it must request, and after using the resource it must release it. And the process may request many resources as it requires for completing the task. It is not mandatory that only one process must request for one resource only. It might be request for more than one resources also. That is based on the work which was assigned for the process. The request arised by the process will vary accordingly. Then the number of process and the resources requested may not exceed the total number of available resources in the system. This is an important scenario. That is nothing but if a process for execution it needs, for example, 10 resources, that 10 resources must be available in the system. For example, if the system is not currently available with 10 resources and it is currently holding only 5 available resources, then the 10 number of resources which is greater than 5 can be allocated for that process. So this is the scenario. The number of requested resources must be lesser than the total number of available resources. Then only that process can be allocated with that resources. For this, if a real-time example is discussed here as the usage of printers. If a system is connected with only 2 printers, it can't access the third printer because the third printer was not available on that system, right? The available number of printers is itself 2, then how come it can access a third printer? So this is the same scenario which is applicable for resource allocation also. The resource which was requested should be less than the number of available resources, then only the resource can be allocated for that process. That is the steps for usage of resources.